So my neighbor gave me this ice cream making machine. They had a problem with it. A gear broke on it. So I'd never actually seen an ice cream making machine before. Turns out it's a refrigeration system, which makes sense, being that it's an ice cream making machine. I have a refrigeration ticket, but all my work has always been on air conditioning and chillers and such for HVAC. Well, I guess I've done a few walk-ins, that sort of thing, walk-in freezers and fridges, refrigeration. But yeah, never anything for food or commercial food processing. Anyways, so this it's kind of an interesting little thing. So first off, the gear, when I popped open the case, this was the gear that he was talking about that broke. And my assumption is I haven't taken it apart yet, but underneath of this chilled container, I'm not sure what you call it in the ice cream making world, I'm assuming like a churn or something like that, there's a cogged belt under here, and those cogs kind of feel like they fit these. So I might just try JB welding this together and seeing what happens. But I figured I'd go over, I was just looking at the little refrigeration system that we have here. So the heart of the refrigeration system is the compressor. So this is a hermetic compressor. It's a little 120 volt, probably, I don't know, half an amp or something like that. Let's see here. Doesn't say. The refrigerant in here, I'm not 100% sure. Oh, hang on. It's R12. So the refrigerant that they use is R12. And usually they tell you how much is in it. I'm not seeing the amount. In Alberta, like, we're actually supposed to keep track of all the refrigerant that comes out of it. I have a refrigeration, air conditioning refrigeration ticket. I've never actually worked on food processing. All my refrigeration work has been on HVAC equipment. So, the heating, ventilation, and air conditioning. I've never done food processing, refrigeration, or big freezers like for the distributors. Done a couple of little walk-in coolers and walk-in freezers, but that's pretty simple. And I've never done the grocery store work, which is like a whole separate thing on its own. But anyways, refrigeration is all pretty much the same. Anyways, the what refrigeration is. So this is your compressor, and coming out of the compressor, this is the discharge of the compressor. And the discharge of the compressor, you have hot vapor coming out of the compressor. It goes into a condenser, and this condenser is cooled by air. There's this fan in the back here that cools the refrigerant, or blows air through it. And as the refrigerant is forced through the coil, it condenses. And so coming out of the coil, you have liquid, and the liquid refrigerant comes into this. This is a little vessel. I'm guessing it's a little vessel. They call them receivers in bigger systems. And so the liquid refrigerant will fill up this receiver, and then it starts spilling out through this. And this is called a capillary tube, cap tube. And that's what they call the metering device. So what happens is there's a pressure drop across this, and that pressure drop is where you go from liquid refrigerant to vapor refrigerant, and you do it at the same pressure, essentially. Well, I guess not the same pressure. Yeah, it's an adiabatic. I'm trying to remember if it is. I'm trying to remember the curve. No, it's a lower pressure. Anyways, it's at the same enthalpy. So the pressure drops, but the enthalpy stays the same. And what that causes is a reduction in temperature. So that liquid comes through here. This is a I forget what exactly they call it. Anyways, it's a way of sort of maximizing your efficiency of your refrigeration system by putting your suction against your discharge or your liquid line. Anyways, so that liquid comes in here, flashes into vapor around, there must be a jacket of some type around the churn. I don't know what this is called again. I say, anyways, a churn. So when it flashes from, when you go from high pressure to low pressure with the liquid and flashes it, you do it at a constant enthalpy, which causes the temperature to drop, and that's where your refrigerated effect comes from. So then that comes out, so you have vapor forming inside the jacket of this, which is sucking the heat out. Refrigeration is actually moving heat from a place of where you want to move heat from one place to another, and the compressor does the work to do that. So the coming back out of this vessel is your suction line, and this is usually the biggest line of your system, because what you have here is cold vapor coming back that goes into the compressor, and that vapor is essentially about 10 degrees lower generally, I guess, than your process. At least that's the way you do it in HVAC. In processing, like food processing, it might be closer. Your temperature approach might be closer to your process temperature. I don't know. I can't remember that. That was all in school. And when I said 10 degrees, I mean 10 degrees Fahrenheit. So like about 5 Celsius. So whatever your temperature in your churn is, so like say it's minus 5 degrees Celsius, coming back at 10 degrees Fahrenheit. So let's say it's at 20 degrees Fahrenheit. You expect this temperature here coming back to be roughly 10. So that's how you get your temperature movement. Anyway, so you have sort of cool vapor coming back through here, which goes back into the suction of your compressor, and then poop comes. The cycle continues. There's a compressor in here, and the interesting thing about hermetically sealed compressors is that the windings of the motor that drive the compressor, so there's actually a little compressor that's just right in here, like a little, in this case it's probably a little tiny single piston reciprocator compressor, but the windings of the motor live inside the liquid, or inside the cold vapor side of the refrigerant. So your windings are cooled by this cold refrigerant coming back, and then it comes, your winding, the heat of the motor gets rejected by the condenser. And typically a condenser is about 25% or so bigger than your evaporator. The evaporator is this part in here, and that 25% is to allow you to reject the heat of that's generated from the work that the motor does. So anyways, go and look and see how this thing works. See if I can get this gear back together. I'm going to try JB welding it, and we'll see if we can get this working. So I JB welded this gear back into place, sprocket, I guess. It drives a belt, I guess a tooth shiv. I think that might be what they're called. The belt that it drives is has teeth in it. So I've been trying to figure out how to run some CAD programs, because I think this is nylon, so it's a nylon gear, and maybe get a new one printed on a 3D printer. I'm kind of working with the CAD programs a bit. I'm not a big fan of CAD. I've never really liked it very much. But I'm going to install it, and we'll see if just the JB Weld works. But I did do a dimension for it. So we'll see. Once I learn the CAD, I'll run up a couple of a file, and I'll send it off to a printer and see what comes out of it. It's a little different than what this guy, because these supports here weren't really enough to keep it from blowing apart. So just kind of the design I did here was to beef up this center part here, and that should keep it stronger. But anyways, I'm going to start putting this back together and see if I can get this ice cream maker to run. So reinstalling this gear looks like it's going to be kind of bit of a difficulty because it looks like I'm going to have to take everything off of this plate. So it looks like we have like a bearing down at the bottom here, also a bearing right here. And in order to get this gear into there and onto the shaft of the motor, I'm going to have to remove everything off of this plate. I might be able to take the motor off, so I'm going to explore that first a little bit to see if I can get this motor. And I don't know if this is like a transmission. Oh, it is too. There's this is a transmission. There's a gearbox right here. So this spins and it doesn't go directly to the shaft here. So that's interesting. Yeah, so I think the easiest thing to do is to take this off, but I might try to get it. No, I'm pretty sure that's the way to do it. I have to be gentle because everything is sort of only held together by the tubing of the refrigeration system. So I removed the screws that holds down the jacketed mixing bowl and this motor mount, and it looks like it comes loose. So I've got to just stick the gear onto that shaft, I think, and reconnect the belt, and I think we'll be good. So anyways, I'm going to try to do that. I can't do it one-handed, and we'll see what happens here. I just pulled out the belt for this ice cream maker. It's a cog belt. Assume, I don't know. Anyways, that should be all the information we need, and saving it for posterity. So I have kind of a problem with this gear. It doesn't fit over the shaft here. There's these little divots right in here, right behind my thumb, line up with these divots on the shaft, which give the gear its adherence to the shaft. But unfortunately, I can't get the gear over onto the shaft. It's too small. So I don't know. I'll have to do a little research. I think the gear is made out of nylon, and maybe you can expand nylon. That might be a bit of a problem though, because I welded it here, and I don't know if the JB Weld will let it expand. Anyways, we'll see what happens. So I'm going to try heating my gear up to 200 degrees Celsius. 200 Fahrenheit, 100 degrees Celsius. So that might be enough to get the thermal coefficient of expansion to be enough to get over. I guess nylon has a high thermal coefficient of expansion, about 3 times as much as aluminum, which is, I don't know, I guess enough. So we'll see if this works. So I'm at a loss how this is supposed to work. I heated up my bearing, or correction, my gear enough, and it actually started to just melt a tiny bit, but it didn't expand enough to press over top of the shaft. So I'm at a loss as to how they actually manufactured this. So this is how it fits on the shaft. I honestly, I don't know how they got it. They manufactured it. Maybe my wife suggested it was in hot water. The whole thing brought up to 100 degrees. I don't know. But anyways, it looks like if you try to heat it with the JB Weld on it, it fails. So I'm going to try just JB welding this in place, which means I'm going to have to clean up the previous weld to see if I can get it going. But we'll try that. So I epoxied this gear around this the shaft. I was actually thinking a bit about how it was manufactured, and my guess, I don't know for sure, but my guess is that there was some sort of injection mold that the shaft here, this shaft was placed inside of an injected mold, and then the plastic gear was injected and molded around the shaft, and then the whatever the injection mold was pulled apart when it was done setting. And I'm trying to. I thought I saw there were some lines on the gear that may have indicated that it was in a mold. I don't remember where I saw them, or maybe the mold was, rather than going in, the mold coming, like going breaking this way, the mold actually was over top of it like that, and maybe this point here was where the mold was broken or opened up. I don't know. Anyways, that's how I'm thinking this thing was made. Um, and so I think in order to replace this, I'm going to have to, because I don't have access to an injection mold or whatever, you know, that does this gear, I'm going to have to manufacture the whole piece if I ever do want to replace it, which would be done in probably, you know, you could probably have it 3D printed. So make everything in nylon, including the shaft here. Have it just one solid piece of nylon, or do it in a solid piece of steel, and just machine that. So, anyways, that's what I'm thinking. So I got this ice cream maker back together. It seems to be working. That gear repair works. Um, so that noise you just heard on is the compressor turning on. The little refrigeration system that cools this guy. It's already getting cold, so that's quick. Um, this is a button that controls the mixing axle, I guess. So you put a timer, and then away this guy here is. You can see it's turning. So yeah, pretty cool. Gotta get some cream and milk and stuff to make some ice cream. See if it works. So before you make the ice cream, you have to provide a solution of it's essentially antifreeze. Um, this case, it's a water salt solution, saline solution. I don't know what the freezing point is on it. Pretty low, and I think what that does is it creates a sort of a jacket around the I don't know, the bowl that the ice cream is mixed in. So you just need that before you start making ice cream. So the recipe for the ice cream is pretty simple. It's half a cup of milk, half a cup of cream. Um, correction, cup of milk, cup of cream, half a cup of sugar, a pinch of salt, and then one teaspoon of vanilla. So 1 cup milk, 1 cup cream, half cup sugar, pinch of salt, 1 teaspoon vanilla extract. Also, before you start making the ice cream, you need to turn on the power here. So we just heard the compressor turn on. You need to run this for about 5 minutes before you put in the ice cream maker. And right now it's cooling the jacket here where I got my finger in. So come back 5 minutes and put the mixture of ice cream in. So the bowl goes into the jacket. The mixing props go into the bowl. You screw it down. The lid goes on it. I don't know where there's a cap, a movable cap that sort of allows air in and out. I don't know how much difference it makes. I doubt it's a whole bunch. And then now you turn the unit on and you put your timer. So 20 minutes is what they recommend, and then it starts making ice cream. So the timer just dinged, and we have our ice cream made. So a thing that I just learned is that if the churner stops, don't restart it, because as soon as this ice cream stops being churned, it sets up immediately. So it happens pretty damn quick, and if you do that, it's like trying to turn concrete, and the belt slipped, which is a good thing because otherwise that gear might have broke again. But that's something that I just learned is let's not turn this back on. So now I can turn this off, turn off the refrigeration, and I've got myself some ice cream. With the bowl and the bowl removed, the refrigeration, this jacket here, so that's all ice that formed from even from this saline solution. So it's it gets pretty cold. I don't know. I'd have to figure out what the freezing point depression is um, of that volume of salt and water I mixed together. But guessing it's probably down around the -20 amount.